So the topic is Google Earth Engine for satellite data analysis. I should change actually satellite to spatial data analysis because Google Earth Engine is not exclusively for satellite data. It is also about other spatial data sets also. GEE is an acronym for Google Earth Engine. Okay, so whenever I say GEE, don't get confused, it's Google Earth. Google Earth, so many people, even myself in the beginning, when I heard Google Earth Engine, I got confused with the Google Earth application, which we have used for, I don't know, last 10, 15 years, at least 10 years. But Google Earth is different, Google Earth Engine is different. So that is the first lesson for those who are really, really new here. Google Earth Engine is much more advanced and a bit complex infrastructure where we can compute data in their cloud infrastructure, Google's cloud infrastructure. So I will take you through some basic facts about Google Earth Engine. Can you see the animation here? This animation is developed in Google Earth Engine, and it can be, yeah, these kind of animations can be created very easily. And it used 30 years of Landsat data in using maybe 10 lines of code. So that is one advantage of having familiarized with Google Earth Engine. So big data analytics, you will hear big data everywhere nowadays, right? I mean, there's big data everywhere in all the applications, and big data is also being heard in agriculture domain as well. So data-driven monitoring and intervention. So that's what we try to do with all our analysis. The water productivity study, which we did in NLBC, is also kind of data-driven monitoring and following interventions. So the recent developments in ICT, information and communication technology, led to enormous data to analyze. So last 30 years, we have high resolution data sets available from Landsat, Sentinel, all over the globe. So it can be Earth observation satellite data cubes, IoT based sensor data, drones, crop models. So it all require higher computing power. So it can, it is reaching a stage where our laptop or our desktop cannot manage a lot of data. There are three major players nowadays in cloud computing. It's Google Cloud, Amazon Web Services, and there's Microsoft Azure as well. Microsoft Azure is also getting popular nowadays. They are also kind of copying Google by providing Earth data, and they have artificial intelligence for Earth programs and things like that. And there are other players as well. Cloud infrastructure is not limited to these three players. There are many other private players. But what brings Google more attractive, because they bring in a lot of value added things like adding a lot of data sets, giving access to data sets, adding a lot of libraries like machine learning libraries. So imagine a GIS software with all kinds of advanced algorithms, vector and raster inbuilt in cloud infrastructure with access to all the data which we need. So that is what Google Earth Engine is for you. Now, they call themselves a planetary scale platform for Earth science data and analysis. Most of these charts are from web, so I should not spend a lot of time going through this. This is the website, earthengine.google.com. That is the master website. If you search Google Earth Engine in Google, you will get a lot of websites, which are all good. But the primary website for any kind of information for Google Earth Engine is this one, earthengine.google.com. So you should start from there when you are a beginner. And all this menu, the data sets, all this menu is well arranged. The data sets will give you an idea what are the kind of data sets available for or accessible in Google Earth Engine. There's a frequently asked questions session, the time lapse, which I showed in the beginning in the first slide. You can go to time lapse and you can create your own time lapse, or you can screenshot or record or whatever you want. There are some case studies, interesting case studies about platform, and there is a blog where they publish important news. Now, sign up for Earth Engine account. So you have to go to this particular link and sign up. Why? So what I'm going to take you through is the components of Earth Engine. Some hands-on. There are two main components. One is Earth Engine Explorer, and there is a code editor. And this hands-on on using the Explorer, I will not do today for you guys because it's self-intuitive. You can do it yourself. But what we are going to do is using the code editor. You're really going to script something. So why we are doing this? Why Google decided, okay, they need a planetary platform where they can, or where scientists or decision makers or engineers like us can process data, because they wanted to answer all these questions about infectious diseases, deforestation, water, climate change, biodiversity, land cover change, and it's becoming a truth, right? You know, a lot of um, scientists are nowadays moving to Google Earth Engine and creating high value papers, journal papers, high value results. So in a way, Google's mission is getting accomplished. Yeah, let's see how we can also make use of this functionalities of this infrastructure and help our studies. Yeah, as I said, one biggest advantage of Google Earth Engine is that in a click or in a line of code, we can access all these data sets. And this is not all, this is just to show you some satellites, but there are many more data sets available. There's Earth Observation Data Archives, which is of our main interest. And when we logged into Google Earth Engine, when we do some kind of computation, the computation actually happens in one of the node in the cloud infrastructure, Google's cloud infrastructure. That is the beauty. The classic remote sensing workflow is we prepare the data, right? We download data. There will be old file formats. There will be NCDF file, HDF file, TIFF file, shape file. There are hundreds of file formats. We deal with all of them. The issue with the metadata, bad missing data, cloud shadows. So we have to do a lot of preparation. So if you consider this as the entire time to do some data analysis, majority of the time is taken for data preparation. And only a few time, limited time we use actually for data science. But what Google Earth Engine offers is we can do all this stuff once quickly with using their cloud infrastructure, so that we can focus on this. That is what Google claims and Google offers us. The Earth Engine public data catalog. So let's see what we have. We have the entire catalog of Landsat and Sentinel data. Landsat. All the Landsat data sets are there. Landsat 4, 5, 7, 8, and I think it is published with 1 week lag time. So last week's Landsat 8 will be already available in Google Earth Engine there. All the MODIS data sets are there. MODIS products are there. A lot of DEMs, SRTM is there. The ALOS DEM is there. Some land cover data sets are there. A lot of atmospheric data sets are there. Climatic data sets are there. So there's a public data catalog in the website available. You can go through that page and see what are the data sets available. And we will see how to call each data set later. Now, this is the link. If you go to developers.google.com Earth Engine dataset, where there you can see all the data sets available. Or else, as I said, let me share a tab. earthengine.google.com, as I said, is the primary gateway to Google Earth Engine. Yeah, the first menu is datasets. If you go to datasets, this is the link. Here you can see that there are they have categorized the datasets into different categories: climate and weather, imageries, Landsat, Sentinel, MODIS, geophysical datasets, etc. Now you can view all the datasets. If you go to all the datasets, then you can see all of them, basically. There is population data available. See, all these data sets are available for you to access. And so this is the catalog, and or you can browse it by tag. For some popular data sets like Landsat, MODIS, and Sentinel, they have created separate menus as well. So it's up to you how much you want to explore. And here you can also see the API docs, which explain the API functionalities are also here. This is actually the documentation page of Earth Engine. You will see all the necessary details required for you to start with Earth Engine. Okay. So I can go to datasets. Here you can explain, and I can go to API docs here, which will take me to the documentation. So that's how I went. Now, coming back to my presentation. So there's a trick. I mean, the basic trick of processing this huge data set is parallel processing. So what they do is they divide the entire image of your study area into, let's say, 256 pixels subunits. Okay, so they divide one image into different grids, different boxes of 256. And all these images, each grid will go to different nodes. That's a different computer or different processors in Google Cloud infrastructure. Whatever algorithm we say, if you are going to classify or if you are computing NDVI, we are computing any other complicated algorithm, it will be done for each frame separately or each grid separately, and it will be joined later. And that is how Google managed to do it in quickly using their cloud infrastructure. So it's a basic concept. We are not going into detail here, and we don't have to. We don't want to know that. Actually, we are not computer scientists, but it just should give you an idea how things are being done in the cloud infrastructure. Now, one of the main feature or one of the main attractive feature is the time lapse. If you go to this particular link, you can see the time lapse. The time lapse is created using 30 or 40 years now, 40 years of Landsat images, and it shows any area in the globe how landscape has been changing over time. You can also create time lapse using other data sets, but then you have to create yourself. But with Landsat, Google has already created it, and you can zoom into any area and extract it. So please go to that link and explore it yourself. We can also try that if you haven't seen it yourself. See here, you can see, so they have selected some area. I can also search here. Let us search, what do we search? We can search Narayanpura. I don't know if we are in Narayanpura. Are we? Yes, we are. Yeah. Anyway, so you can go to any places and you can basically see the changes over time. Oh, you can share this time lapse like this. So if somebody is connected to internet, you can share this link. And I can share this link here. To open that link, it should open to this particular view. So that is one way of doing it. Okay, and I'm sure I have done it before. You can also export this time lapse into a MP4 or a video file for your own presentation, play it in your computer. But I think I did it with a third-party application. Yeah, so this is time lapse for you. Then there are many applications available developed in Google Earth Engine. The Google applications. So this one was done and published in Science on Global 21st Century Forest Exchange Engine. It's a very good very good study actually. They processed the entire globe using Landsat data and extracted the forest changes over the last 35 years. And it was published in Science. I think it was some university in US, Maryland, I guess, I'm not sure. But yeah, this was one of the major application during the beginning of Google Earth Engine. It was published in 2013, so already 7 years. Yeah, so they used, you can see 650,000 Landsat images, 12 years of data. Yeah, I don't know, 10 lakhs or yeah, 10 lakh CPU hours of computation, 10,000 CPUs used, and in Google Earth Engine itself, it took 4 days to complete. This is another application which is very interesting. It is done by Global Surface Water Explorer. Sorry, it is done by the European Commission's Joint Research Center. It shows the global surface water change over time. Maybe some of you have already seen this. You can also download the data. It shows the water changes over time at very high resolution, at 30-meter resolution. It's very useful how water has dried up, the permanent loss of water, the seasonal loss of water. You can see different layers here. And it is also done globally. So this is also a very famous application of Google Earth Engine done by a group of scientists in Joint Research Center in Italy. Again, some statistics which shows, yeah, you cannot actually do it in a computer. You need something like this, right? They process 30 lakhs Landsat images to come up with this kind of data sets globally. Now, yeah, just to show you some examples. These are the time lapse of Las Vegas. Now, the components of Earth Engine. Now, let's get into some serious stuff. Okay, so let me just go to the next part, the components of Earth Engine. So Google Earth Engine can be accessed in different ways. One of the most popular, and they also prefer us to do that, is the code editor. And the link is code.earthengine.google.com. The code, the scripting, which you will do is JavaScript. Many people confuse it with Java. Java is different, JavaScript is different. Both are completely different. JavaScript is something which we usually use in web applications or websites. And then there is explorer.earthengine.google.com, which I'm skipping here, but you can all go in and explore yourself. There's no coding required, but very limited functionality. So once you see the power of code editor, you will not feel like going back to Explorer again. Explorer can do only a very few functionality, which is disappointing. And there is Python API. It uses Python coding, but very advanced level. Right now, it is you need to know some command line, and it's also it is also not matured enough. So maybe in the coming years they will put more effort in making Python API. But it works. It really works if you want to run things in a server, not in a browser. And there's Earth Engine apps, the user interfaces which people have created. You can explore, like the one which I just showed you, the Global Water Explorer, which you can go. So the code editor, the link is code.earthengine.google.com. It's a web-based environment for performing analysis, investigating data sets, managing scripts, and building interactive tools. The Explorer is, as I already mentioned, a simple interface for performing visualization and classification tasks. Explorer drives a substantial portion of Earth Engine traffic, but still it is not, the functionalities available in Explorer is very limited, and you cannot do any spatial data analysis there. You can only do some classification there, and also there is limitation in exporting, importing data and stuff like that. So I'm not very, I don't use it much. I only use it for some demonstration purpose when I'm beginning my course here. Then there are many Earth Engine app. It's very interesting. If you go to this link, you can see a lot of applications developed by experts. Hopefully it will show up here. It's earthengine.app. So you see a lot of curated applications developed in Google Earth Engine.